Hey Gabriel, thanks for the question. We're Alex and Maya, and we researched all about weather, and we're going to explain it to you today. Turns out there's a lot to weather out there that we can learn about. Basically, weather is what the atmosphere is like at a certain time and place. The atmosphere is this layer of gases surrounding the Earth, kind of like a force field. Weather includes things like heat, dryness, sunshine, wind, and rain all interacting together.
There are a couple of these main parts of weather that we will talk about today. There is temperature, precipitation, wind, moisture in the air, and cloudiness.
But first, it's important to know the difference between weather and climate, because these words can get mixed up a lot. Weather is the short-term condition of the atmosphere. Climate is the general weather of a place for a very long time, so it's more long-term, where weather is more short-term. Weather is what you get in the moment, and climate is what you expect to get, based on what usually happens. You would use words like hot, cold, wet, and dry to describe the climate of a certain area. The climate for a desert would be hot and dry, but this is only what a desert is usually like. The weather for the day in a desert could be rainy.
It's also important to know, why do people even study weather? Weather is studied to get an understanding of how the atmosphere works, so special atmospheric scientists can predict the weather ahead of time and change the weather more successfully, such as making big storms less big, so less destruction occurs as a result. Weather forecasters use things like weather observers, weather balloons, weather stations, and satellites to predict the weather.
So scientists need to learn what causes certain types of weather in certain places to happen before they can even begin predicting and changing it. For any land area, there are causes for weather having to do with how much energy you can get from the sun, called solar energy. The amount of energy you get from the sun is different based on where you are on the earth, called latitude, how high up you are, called altitude, how close you are to mountains, how close you are to a lot of water, number of disruptions to the atmosphere that make hurricanes and thunderstorms, called storm systems, and air pressure. These cause different winds and air movement patterns. That's why in a lot of places, weather has a pattern and changes as a result of the day and night cycle, and even daily, monthly, and yearly cycles, because the sun is out during the day and not at night. And because the sun is closer to parts of the earth during certain times of the year, it causes different weather to happen.
We are going to use the United States as an example of weather and the place to show how the causes of weather work. The United States is near a lot of water, such as the Atlantic Ocean, Pacific Ocean, and Gulf of Mexico. Having the Gulf of Mexico right near our southern states affects their weather because of the special relationship between water and solar energy. Remember when we said that one of the causes of weather is how close you are to a lot of water? This is showing why. The water is heated up because of the sun's energy, and the closer you get to the equator, the halfway line around the earth, the better and more direct the sun's rays can hit the earth. This makes things more hot, so the liquid water in the Gulf of Mexico can turn into gas in a process called evaporation. This gas is called water vapor. This really warm and moist air example will become important later when we talk about how clouds are made. It's because, as we will learn, the warm and moist air is a lot less dense than cold air, so it's going to rise, and the water vapor will do the reverse of evaporation and condense.
Now, if you travel to the north, you are a lot farther away from the middle of the earth, so the sun's rays don't hit as directly. It doesn't get as hot because the intensity of the sun's rays isn't as harsh. Therefore, less water is turning into water vapor, and the air is more dry. Also, side note, remember how high up you are on the earth was another cause of different weather? Like if you were on a mountain versus in a valley? It actually works just like if you were going from the equator to the poles, aka the ends of the earth. The higher up you go on a mountain, the more cold and dry it gets. But back to our example, the warm, moist air of the south and the cool, dry air from the north meet in the central parts of the United States. These air movements cause differences in weather in different parts of the United States, such as no rain, too much rain, and really big storms like hail, ice storms, and tornadoes.
So let's move on from causes of weather to what the main parts of weather are. Weather is made up of wind, temperature, pressure, moisture, and precipitation. So let's go through each one of those and see what they are.
First off, let's talk about moisture and temperature. Both have to do with water. Now, water can be a liquid, gas, or solid. At really high temperatures, it is a gas. At medium temperatures, it's a liquid. And at cold temperatures, it's a solid. When the temperature is warm, water and big bodies of water start to evaporate, like we talked about, into water vapor. This water vapor makes the air more moist. And what's cool about air is that if the pressure stays the same, the higher the temperature of the air, the more water vapor it can hold. When air can hold all the water vapor it can at that certain temperature, the air is saturated. Clouds are a good sign of a lot of moisture in the air. That's why it gets cloudy. Clouds happen when water evaporates from bodies of water, enters the atmosphere, and collects in small particles in the air and forms clouds. When enough water collects in a cloud, it rains. If the temperature is low enough, it snows.
That leads us right into precipitation. Rainfall is different from place to place. For example, Buffalo, New York, Kansas City, Kansas, and Seattle, Washington, all by the end of the year get the same amount of overall rainfall, about 35 inches. But in Buffalo, the rainfall evenly distributes throughout the year. In Kansas City, it mostly rains in the warm season, and for Seattle, the most rain happens in the winter.
Then we have pressure. What do we mean when we say air pressure? Well, imagine this. A column of air that has its bottom at the top of the ocean and its top at the atmosphere. This column of air, if you put it on a scale, would have weight, because air is made of gases and gases have weight. Therefore, gravity can pull down on these gases and it causes pressure.
Now, there is an air pressure that is considered normal, but the air pressure can be way different than normal under certain circumstances, such as when you're higher up on the earth, like on a mountain. That column of air that we talked about gets shorter, so there is less weight and therefore less pressure. Like if you had a really tall guy standing on an empty cardboard box, he would probably have enough pressure because he's so heavy that he would crush the box. But if he were made a lot shorter and stood on it, then he probably wouldn't have enough pressure to crush it.
Remember, when this air warms up, it gets less dense and lighter, so the air rises. As the air is rising, it is using up energy and becomes cooler. At some point, the air will reach a point where it isn't warmer than other air around it anymore, so it stops rising. This is where water particles and water vapor can slow down because it's colder and they lose their energy and start to collect together and form a liquid again in clouds. These clouds, once full of a bunch of liquid, then eventually rain, snow, or hail. That's why warm air means lower pressure because all of it is rising, and cold air, being dense and not rising, means high pressure. And low pressure means lousy weather.
Now let's talk about wind because it has a lot to do with high and low pressures and air rising. Remember how we said that the equator gets more direct sunlight, so it's hotter there than at the ends of the earth? Wouldn't you think that would mean that the equator would just be getting hotter and hotter and the poles would be getting colder and colder? Well, that doesn't happen. Because air moves, cold air and warm air can move around to heat up or cool down a place. This is called circulation.
Here's a simple circulation model. Since air at the equator is heated the most, it rises. So warm air would rise at the equator and move towards the ends of the earth. The warm air moves to the ends of the earth because there's more space there since the cold air there isn't rising as high as the warm air at the equator. Cold air sinks at the ends of the earth and moves along the surface toward the equator. That's why the northern half of the earth will always have wind coming from the north. This model is not actually how the world works exactly because we live on a rotating planet, so it complicates things just a little bit more. The Coriolis effect occurs and the actual circulation pattern is quite complex, but we don't have to get into the nitty-gritty of that right now. Just remember, high pressure at poles, low pressure at equator, and wind moves from high pressure to low pressure, like it's getting squeezed out from all the pressure. So those are the causes for weather, Gabriel. I hope you learned a lot because we sure did.